All right, so I'm gonna go over this one. Might be best to not copy anything yet. So I want you guys to just maybe start by just looking here, and I'll give you some time to copy, okay? So we're gonna get an inclined plane. Okay, I'm gonna put an object there. So it's starting from rest. You lift this table, this is what we did, to some angle until this thing starts to move. So it starts to move this way. So when that happens though, this net force here is going to be equal that of that frictional force. But no one pushed it, right? No one's pulling it or pushing it. So let's finish the free body diagram here. So you got your FG. So this one, no problem, you guys can do the FG. Okay, this is when it gets tricky, the FGX and FGY, right? So when I continue here, basically what I'm extending is the F of N. So you want to make sure that this is straight up and this is straight down. And that will be your FG of Y. This thing is drawn, this thing is drawn parallel to the inclined plane. So it's like the number 11. Okay, so this is your FG of X, and that's the angle. We don't have any problem with writing the FBD on an angle now, right? So this is when I see some trouble would be when this one is drawn not parallel with this one. That's the only trouble that I've seen. So why don't you guys put your free body diagram now without looking. You don't need to copy this one. Just go ahead and put a free body diagram and don't look at my picture right here. Make your diagram, big enough that you can see all the forces. Okay, so we got the free body diagram. Okay, how's your free body diagram? Look up here. Got that right? Looks exactly the same, right? So step 2, you're going to split it up. It's like taking a machine and you're figuring out how it works, so you separate the components, right? So we're going to split the X and the Y components now and write the equation. So I'm going to ask here, I'm going to add here, you're going to write the FBD equations. Okay, so the X and Y will have a separate equation because they're independent. Okay, what are the X component? Now, this is when, if you take a look here, it's an angle, right? But really, it's just kind of like this. So you have your Y component like that still, okay? And your X component now like that. So when you're looking at it from this way, it's exactly like the one we've been doing before. So if you look at the X components, what are the X components? The X component would be this one here and this, right? And notice there's also one down here that is pointing to the left. So let's label our X components with the positives and negatives. Which one of those will be the positive component? Net force. Always start with the net force because that would be the potential motion, right? So that's the positive. What else would be positive? FGX. Anything else in the X component? Okay, that's it for the positives. The other one would be opposite, so it's got to be the opposite of the positive, which is negative. We okay with that? Okay, so that's the X component. So let's write down the FBD equation for the X component now. And the equation always starts with sigma F. So net force equals everything else. So what would be the equation here?
FGX minus frictional force?
That's right, because you're just writing it down, right? Okay, so go ahead, you can write that down with me now. So FGX minus FF, positive minus negative, right? So if the object just begins to move, we could say that the net force is equal to 0. Now think about that, why that makes sense. When you were lifting the desk, okay, the object was still stationary until you lift it enough to give it enough Fg of x. The Fg of x is what is causing that box to slide. Do you understand that concept? So if that is equal to the frictional force, then it will begin to move. It actually has to exceed that a little bit. So this Fg of x then is equal to the frictional force. This is the most important part right here of that equation. Take a look at the y component. Okay, I'm gonna just tilt this a little bit again. These are the y components. Is the box moving up or down? Meaning, is it going up this way or down this way? Is the box actually leaving the table? No, it's not. So then there is no vertical motion at all, right? If there's no vertical motion, what can you say about the net force?
0.
Okay, in this case, there is no net force, so we can write the equation as Fn minus Fgy equals 0. So what can we say about Fn and Fgy? Go ahead, write that down. So you got Fn. They are equal to each other in terms of numbers, right? Opposite direction. So that is the equation for the y component. Okay, so we have separate components right now, right? I'm going to put step 3 right here. Step 3 is you're going to unite or unify the x and the y component equations. We're going to combine them. See, equations are like, you have a system. This is our system. This picture right here. You're figuring out what's happening, so you split it up. You break it down. It's like a machine. You opened it up. You look at the parts. You got the x and the y parts. Once you've figured out how they work inside, you're putting it back together. That's step 3. You're unifying it. So how do we do that? What do they have in common, right? What do they have in common? And then we're going to combine the two. All right, so I'm going to rewrite the equation here for the x component. So we have Fgx equals Ff. And then here for the y component, I'm just rewriting. Okay, so we're going to now expand this first. Let's expand. Meaning we're still opening up the Fgx. Okay, go back to your picture. This is, I'm going to redraw it right here because people have a hard time when it's at an angle. Look at that picture right here. Okay, see that? I'm just going to redraw it exactly just how you see it right here. Okay, look at that picture right here. It's exactly the same as that one right here. Okay? So that angle is whatever angle you had to move that object. That's the theta. Doesn't matter. We're not going to put any numbers right here. Okay? So that's the Fg of y. This is Fg of x. Do you remember this part right here? The hypotenuse is the Fg. Right? Fg is the hypotenuse. Okay. So how do you find the Fg of anything? What is Fg equation for Fg? What is it? M times G. So you find that by taking M times G of whatever planet you're on, right? So if I'm looking for Fg of x, which is down here, how do I find this? This is when, again, your trigonometry that we practiced in the beginning will come back. SOHCAHTOA. So if this is my angle, I'm looking at opposite and hypotenuse. So this will be sine. All right, so then this will be expanded as mg sine theta. Is that okay? Okay so far? That's just simple trigonometry. Frictional force. How do we calculate frictional force? We learned that as mu f of n. That one I'll even give you that one, but that's mu f of n. It's easy enough to remember. Frictional force is just mu and the surfaces in contact. Texture multiplied by the surfaces in contact. F of n. Well, how do we figure out what f of n is? That is when you incorporate the y component. See right here? Well, what's f of n? It's fgy. Go back to your diagram right here. What is balancing this f of n so the box isn't going off the table? It's the fgy. Gravity on the y-axis is holding it down, but not fg. It's fg of y. Okay? So we know that is fg of y is fn. Let's expand the fg of y. This one right here. So let's do a little bit of trigonometry. So we go adjacent over hypotenuse. What's adjacent over hypotenuse? Right? So this will be fg cosine theta, which is mg cosine theta. So there's your f of n. You've identified that. So what do we do now? I'm going to go back to the x right here. I'm just going back and forth between x and y. So I've got frictional force, which is mu f of n. You see this f of n? That's the same f of n right here. I'm going to expand it right here. I'm going to do one more step. There. Rewriting mg sine theta. Just rewriting it. This is equal to now mu. What do I do with the f of n? Put this in. Put this into there. Do you understand that part? We are substituting. We're combining the x and y component because they're the same thing. This x and y are actually part of that free body diagram right here. We're just putting it back together. So f of n is mg cos theta. Look at this, mu mg cos theta. So this is where we're at. We have put the y component into the x component. Now they're combined. So we're going to just work on this equation. Let's take a look at that one. Can we now simplify it? Can we simplify this equation? What do they have in common that you can get rid of? Mg. This mass will cancel this mass because it's the same mass. It's the same object, right? The g will cancel both sides. Look at what you have. Can you tell me what we have here? We have sine theta equals mu cos theta. So far, right? Okay. Can you isolate? Go one step ahead of me now and isolate the mu. Go and find the mu. So what is mu equal to? Mu is equal to sine theta over cos theta. Okay, now we're going to do one last step right here, okay? Do you remember how to find the sine theta? Opposite over hypotenuse, right? Look what I'm going to go. Opposite over hypotenuse divided by, what's cosine? Adjacent over hypotenuse. Look at this. I'm going to just rewrite this so it looks better. Opposite over hypotenuse times hypotenuse over adjacent. I'm going to assume you can do the math here. Okay? And look what happens with the h. We are left with opposite over adjacent, which is tangent. We just derived a trigonometry identity. So in the end, how do we actually find the mu when you have an angle? Tan theta. That's it. All that work that we did is just tan theta. So how do you find the mu of anything? You put your shoe on that table, for example. You're wondering, okay, what is my mu between my shoe, the bottom of my shoe, and this desk? Put it on a table, start lifting it, figure out what that angle that is, take the tan of that, that's the mu. So easy. Mu equals tan theta.